Hi guys, today I'm going to be explaining to you the second lesson of Saxon Advanced Mathematics. This lesson is all about the area, surface area, and volume of different solids. Today we're mostly going to be dealing with three-dimensional shapes, but we're also going to be talking about a couple of triangles. So let's start off. To start off, we'll talk about area. But to understand area, first you have to understand how area happens. Alright, so I've got a rectangle. It's got 4 right angles. Right? Now, the units are 2, 3, and then since it's all right angles, it's a rectangle. 2, 3. Alright? And it can be broken down like this. Right? Now, if you draw lines between everything that's opposite to each other, you end up with 6 units. 1, 2, 3, 4, 5, 6. Now you say that this rectangle has an area of 6 units squared, right? And this number of squares always equals the length times the width equals area. So we define the area of a rectangle to be the number that equals the product of the length of the rectangle and the width of the rectangle. Now, a rectangle can be broken down into triangles. Honestly, this is pretty basic, so I'm going to skip over it pretty quickly. Okay? We're going to want an abstract triangle this time. So H, B, B, and H. Alright? Now we're going to cut across the rectangle with diagonal D. Now, you'll notice that the red that I'm shading in right now is a triangle. Sorry. Excuse me. So, this is a triangle. And you'll find that this triangle is the exact same as this triangle. So the white triangle and the red triangle are the same. Now, why are these triangles the same? It's because they have the exact same 3 sides. For the red triangle, the sides are B, H, and D. And for the white triangle, the sides are B, H, and D. So, with any triangle, any right triangle, it has to be a right triangle. You just multiply it. B, base, height. You pretend that's a square, right? And then you divide it by 2 to get the area of the actual triangle. So this is where you get the formula base times height over 2. Now, we run into a problem when you get a triangle like this, which is not a right triangle, or a triangle like this, which is also not a right triangle. So for this one, you need to find the height, which is found by constructing a diagonal. This is the height. You can use the Pythagorean theorem to find the height if you know the measure of this and this. Or you can use trigonometry, but that's later in a lesson. And for this one, you find the height similarly. That's the height. Alright, now that we've gotten that covered, the area for any triangle is 1/2 the base times the height. There's another formula to find the height of a triangle, not the height, the area of a triangle, but it's more advanced. So, let's talk about cylinders. This is a cylinder. This is also a cylinder. However, sometimes we can call this one a right rectangular cylinder because it's rectangular and it's right, meaning it's upright. It stands upright. Or we can call this a square prism because it's a square and it's a prism, meaning the square just keeps extending outwards. And it doesn't have to be a simple shape. A cylinder can also look like this. Oh. Like that. Now that's a cylinder. That's still a right cylinder because it's upright. You can tell it's upright. So to find the volume of this cylinder, it's equal to the product of the area of a base, area of base, multiplied by the height. Let's just call it the height for now. So if we zoom in on this thing and we find that the area of its square base is, let's just say it's 2 and 2. The area of the base is 4. So we do 4 multiplied by the height, which let's just say is 10. 4 multiplied by 10. So our volume would be 40 units cubed, because volume is always measured in cubed, unless you're dealing with fourth dimensional stuff, which we won't be getting into yet. But we again run into a problem. If we get a cylinder that's like this. Now it's a cylinder, but as you'll notice, it's slanted. It isn't upright like all of these, it's slanted. But you can still find the height. It's the vertical distance between the two bases, right? So you could even have a cylinder like this that's really slanted. And the height would be about one line of these pages, because that's the distance between the two bases. But for this one, the height is 2, because it's just 2 lines of the pages. And we'd have to find the area of this circle and multiply it by 2 to get the volume of the cylinder. Alright, let's do a practice problem. The base of a right cylinder 10 centimeters high is shown. So this is the base of a right cylinder 10 centimeters high. So the cylinder is going to look something like this. Alright, and this is going to be 10 centimeters. And we have to find the surface area for this cylinder. So we've already know how to find volume. Now the surface area is going to be the two bases multiplied by this little part. First we'll find the two bases and then we'll worry about this part. Alright? So first, to find the area of this base, we'll do 6 multiplied by 5. That's 30. So now we've found the area of this little rectangle. Now we need to find the area of this semicircle. So plus, how do we find the area of a circle? That's going to be 2 pi r, as we discussed in the previous lesson. But this is a semicircle, so it's 2 pi times the radius, which is 3, and we're going to divide it by 2 because this is only half of a circle, equals 30 plus, and these 2's cancel out, 3 pi, and that's the base. Now since there are 2 bases, there's 1 base on the bottom, right there, and 1 base on the top, we have to multiply this by 2. So that's 60 plus 6 pi, right? Now, we need to find the height of this thing. So, that's a little bit tricky, but we can understand it, right? We just need to find the circumference around this circle, and we need to find the perimeter around this triangle. So we just need to find the perimeter around this shape first, and then we'll just give it height. So we find that it's 5 plus 6 plus 5 plus, and the formula for the, oh no, I got this wrong. It was actually, I gave you the wrong formula for the area. It's pi r squared. So this one's 9 pi divided by 2. That's 4.5 pi. Hold up, we're gonna go again. So this is 30, but this isn't pi multiplied by 3. R squared divided by 2. Pi r squared divided by 2. So we need 9 pi divided by 2. 9 pi divided by 2. And we get 4.5 pi. So that's 60 plus 9 pi. Alright, now that's a real base. Alright, so sorry to take you off on a tangent. Now we get 5 plus 6 plus 5 for the perimeter. And then we get 3 pi. For real this time, I promise. Okay? Because that's the perimeter of this half circle. The perimeter of a full circle would be the pi times the diameter. And the radius is half the diameter, so this is the perimeter of the half circle. And now, if we put this thing flat out, we'd get a couple sections. 3, 4. This section would be 5, this section would be 6, this section would be 5, and this section would be 3 pi. And all of these sections would be 10 centimeters tall. 10. Now to find the area of this middle part, we need to find what the area of this is. We know that the heights are 10, and we know all the bases. So we do 5 plus 6 plus 5 equals 11, 16. So we need to do 16 multiplied by 10 to find the area of all 3 of these in one shot. 16 times 10 is equal to 160. Now we do 3 pi times 10 plus 3 pi 10 equals 160 plus 30 pi. Now we found the area of the side. And we've also found the area of the bases. We just add them both together. 160 plus 60 plus 30 pi plus 9 pi. And you get 220 plus 39 pi. And then you could also solve that out, but I prefer not to, because this is an exact answer. If you put pi into decimals, you don't get an exact answer. So I just leave this as the real answer. If you want to solve it, you are free to use a calculator. You're in Precalculus. You should be allowed to use a calculator to multiply something. Now, we've got another. This one's a bit trickier. How would we go about solving this? If you want, you can pause this video and try to figure it out. Alright, I'm assuming that you paused the video and tried to figure it out. So, first I'm going to go around trying to solve for the front. Because this is still a cylinder, right? There's a base and there's a base in back. And there's two things connecting. Because as we drew on the first page, there's a base, and there's something connecting. That's a cylinder. Now we're going back here. So first we're trying to find the area of the first base. We know that all the dimensions of the lines on this base are 2. So we need to find the area of just one of these squares, and then we multiply it by 5. So 2 times 2 is equal to 4 times 5 is equal to 20. Because there's 5 of these. Okay? So we found the area of one base. And now we found the area of both bases because I multiplied the area of the first base by 2. Now, we need to find the perimeter of this so that we can multiply it by 6 to get our area of the side. So, we have 2 plus 2 plus 2 plus 2. Or, we could just see that there's 3 2's on each little block. And there's 4 blocks. So we could do 3 times 4 is equal to 12. That's the amount of 2's there are. So 12 times 2 is equal to 24. And now to find the area of the sides, we multiply that 24 by 6, which would be equal to, let me get out my trusty calculator. 24 times 6 is equal to 144. That's the area of the sides, and that's the area of both bases combined. So 144 plus 40 is equal to 184 units squared, because we're finding surface area. Great job. If you got that answer, you're right. Now, next problem. Okay, we're going to speedrun this because I already explained it. If you can pause the video and solve it, you're free to skip this. I'm just going to tell you the answer real quick. The answer is 15.14 meters cubed after you put in pi for 3.14. So let's start. 2 times 3 is equal to 6. So now we found the area of this. Now we need pi r squared over 2 is equal to 1 squared pi, 1 pi, because 1 squared is 1, over 2 plus that 6 is equal to our base. Now if we multiply that by 2, then we get 1 pi plus 12. That's not an exponent, that's a multiplication. Alright? Now this is the area of... Oh, this is a cone, it's not a cylinder. Cones are different. You just take the area of the cylinder, so you pretend this isn't a cone, you just pretend this is a cylinder. Like that. And then, after you get the volume of this, you just divide it by 3, because you see 1 cone, 2 cone, and 3 cone in a cylinder. You just get rid of these 2 cones by multiplying it by 1/3, and you get your area. So we were on the right track, but we need to divide it by 3 at the end. So this is our area of both the bases. Both bases. Now we need to find the height, which is 6 centimeters. So we get 6 multiplied by 1 pi plus... Oh, hold up. We're trying to find the volume. So the volume only requires one base. So it's 1/2 pi plus 6 multiplied by 6. Right? Because you got that. Then you just multiply by 6 to get the area, which is equal to 3 pi plus 36. Right? Now, 3 pi plus 36 is our area of the cylinder. So we divide that by 3. to get our area of the cone. Now we have, let's start with this one because real numbers always first. 12 plus 1 pi. And that's pretty straightforward. Alright, next. We have a right circular cone. So that's going to be like that. The volume, so they're giving us the volume. Volume equals 6 pi centimeters cubed. Now the height is 2 centimeters, so 2. And we have to find the radius of the base of the cone. So a real important skill in mathematics is being able to derive a formula whenever you want one. So in this case, we want a formula for the volume of this so that we can put this and the height into that to find the radius of the base of this cone. So we need to find the base, multiply it by the height, and divide by 3. So first, what's the volume for the base of a circle? What's the volume for a circle? So the formula for the area of a circle is pi r squared, right? Now, we're going to multiply that pi r squared by the height. So that's the height. And then we're going to divide that all by 3. And that is equal to the volume. Now we need to plug in the height and the volume. So the height is 2 pi r squared over 3 is equal to the volume, which is 6 pi. Right? Now we have, we'll take this one over. So we have 2 pi r squared over 6 times 3 is 18 pi. So the pi's cancel out, and this becomes 1/9 r squared equals, now since we divided it by 6 pi, that's going to be 1. Alright? Now we take the r squared and divide this equation by r squared. So we get 1/9. Well, that's actually not really good. So how are we going to get this r squared? How are we? We need to multiply both equations by 9. So we get 1r squared equals 9. If r squared is 9, then can you guess what r is? The radius is going to be 3. And there's your answer. Alright, just making sure you can still see. Now, we're going back to 2.4. We have the radius of the base of a right circular cone is 8 centimeters. The slant height of the cone is 10 centimeters. Find the surface area of the cone. So, this one is a little bit tricky because it gives you the slant height and you don't exactly know how to do stuff with the slant height. So in case you don't know, this is the slant height, SL. Alright? So the formula for the lateral surface area of a cone is pi radius times L, where L is the slant height. Alright? So we multiply pi by 8 by 10 to get our lateral surface area, which is 80 pi. Yeah? Now, next, the surface area for the circular cone is the area of the base plus the lateral surface area. So we just found the surface area for this top part, and now we need to find the base of the circle. And that's pretty easy. We just do pi r squared, which is equal to 64 pi. 85 plus 64 pi. Again, my calculator, or not. 144 pi centimeters cubed. That's our answer. Let's keep going. This is our last one. After this is over. 2.7. So, the surface area of a sphere is equal to 4 pi r squared. Don't forget that. And the volume of the sphere is 4/3 pi r cubed. Don't forget that either. These two are important formulas that you'll probably need later. Alright? So, we needed a sphere with a radius 9 meters. 4 pi 9 squared is equal to 81 times 4 pi equals 324 pi meters cubed. If you remember this formula, it's really quick. But if you don't remember this formula, you keep going through a bunch of derivations. You have to go through the first dimension, the second dimension, and then the third dimension. It's really weird. And the volume's even harder. But if you do know the formula, you'll just plug it in. What's 9 cubed? 9 cubed? 729. Oh, if you're thinking about my calculator, I have the Casio FX 991 ES Plus. It's a mouthful. Casio FX 991 ES Plus. But this calculator is fairly cheap. It comes around at 20 bucks. And it does a lot of great stuff. It can do a bunch of stuff. This is basically a graphing calculator, but it only costs $20. I love this calculator. Alright. So, we'll just finish this problem up. The volume is going to be 972 pi meters cubed. There you go. I hope you enjoyed the lesson. I'm going to go through the entire Algebra 3 book and explain every single lesson. So follow